Hey class, in today's lesson we're going to talk about radian and degree measure, which is found in section 4.1 part 2. Our objective is to use radian and degree measure. So another way that we measure angles is in terms of degrees. So a measure of 1 degree is equivalent to a rotation of 1/360th of a revolution. We actually kind of already know degrees, or kind of have an idea of degrees based off of geometry and just angles, and what we know about angle measure up to this point. However, what we're going to learn today is how to convert back and forth between radian and degree measure. In other words, how does Miss Richardson know, that a certain radian is whatever in degrees? All right, so the way that we do this is to convert degrees to radians. You multiply by pi radians over 180 degrees. So what I'm going to do is I'm going to write this as a fraction so that we understand. So we would multiply it by pi radians over 180 degrees. If we're trying to go from degrees to radians. Okay, if you're trying to go from radians to degrees, then you multiply by 180 degrees over pi radians. And we'll see this, and like you never actually need to memorize which is which. The only thing you have to understand is how to essentially how to cancel fractions. So let's take a look at that. So our first problem says express each angle in radian measures. So I have 135 degrees. So 135 degrees. So I'm trying to go from degrees to radians. So the way you cancel fractions, essentially think about it like this is over 1. You typically cancel diagonally. So what I'm going to do is I'm going to multiply by pi radians over 180 degrees. That way I will be able to cancel my 2 degrees. Does that make sense? Okay, so what we're going to do, if you multiply straight across, that would give you 135. And actually, I'm going to go ahead and start canceling. So the 2 degrees cancel. And that leaves me with 135 pi radians over 180. And then from here, all we do is reduce. We don't typically need the word radians anymore. We just leave it as like pi. So 135 pi over 180 pi would reduce down to way down to 3 pi over 4. Okay. All right, the negative 270 degrees, again, we are going to set it up as negative 270 degrees. And again, because you want them to cancel diagonally, right, because it's over 1, I'm going to multiply it times pi radians over 180 degrees, again, so that my degrees will cancel. So technically, I'm left with negative 270 pi over 180, okay? They will reduce all the way down to negative 3 pi over 2. And again, how am I knowing to reduce? I'm choosing some number that they both have in common, and I'm dividing. So like negative 270 and 180, they both share 90 in common. So if you divide negative 270 by 90, I get negative 3. If you divide 180 by 90, I get 2. So that's how I get 3 pi over 2. All right, so on this one, we want to convert 60 degrees to radians. So 60 degrees to radians. So again, if I want to do that, I need to multiply by pi radians over 180 degrees. Again, those degrees will cancel, and I'm essentially left with 60 pi. That's 60 pi over 180. If I reduce them, 6, well, first of all, look at it like that. The zeros cancel now. 6 over 18, that's 1/3, right? So that's pi over 3 is the radian. All right, now we're going the other way. Now we're going from radians to degrees. So negative pi over 2 radians if I want to change that, essentially what I'm going to do, and we don't really deal with the radians word very often. We only really kind of deal with it like in the second one where you don't see the word pi, and so radians will have to stand on its own. But for this problem, I'll keep it, but moving forward, you really won't see me convert with radians with it. Anyway, because it's pi radians, that means the pi radians has to be on the bottom. So this is 180 degrees over pi radians. Okay, the pi and the radians will cancel out. So this becomes negative 180 degrees divided by 2, which is negative 90 degrees. Negative 90 degrees. 2 radians. Again, so this is really the only time that I typically use the word radians. Okay, so on here, again, I'm trying to convert it to degrees. So I'm going to multiply by 180 degrees over pi radians. Notice in this problem, there is no pi to cancel out with it, so the pi actually stays in the denominator. So this is 2 times 180 degrees divided by pi. And what that's going to give us is a degree that's about 114.59 degrees. With radians, we always typically leave them as fractions. No matter how ugly the fractions look, we leave them as fractions. Degrees, you typically take them out of fraction form and change them to some form of a decimal. And just for us, we don't really need to go past the 100th degree, so this should be fine. All right, so arc length. So remember the radian measure formula is theta equals S over R. So where S is arc length and R is the radius and theta is the radian measure. So to find arc length, we use S, so that would be S equals R theta. So looking at our last example, it says a circle has a radius of 4 inches. Find the length of the arc intercepted by a central angle of 240 degrees. So the formula says S equals R theta. Remember, S is arc length, which is what we're hoping to find. R is pretty obvious. R would be radius. And theta is the angle, but it must be in radians. And what we were given was 240 degrees, and degrees is not radians. So we have to convert that first before we start manipulating this problem. So 240 degrees, if I want to change that to radians, I would have to multiply by pi radians over 180 degrees, or just really pi over 180. The degrees will cancel, so I'm left with 240 pi over 180. They should both be able to be divided by 60, and that would leave me with 4 pi over 3 as my theta. So if I continue to solve, R, which is 4 inches, times the radian, which is 4 pi over 3. If I multiply straight across, my arc length would be 16 pi over 3. And that's it. Guys, if you have any questions, please be sure to come see me for tutoring.